Точно слышно? Test, test. All right. All right. Welcome, everyone. So we're starting. Take your seats. We're just 5 minutes late. It's completely fine. So the less people coming in. Hello. Can you please close the door behind yourself so we have a bit more cozier setup? All right. It's not that easy. Yeah, we'll start without it anyway. So welcome, everybody. It's been a while since React Amsterdam Meetup been on this stage or on any stage in Amsterdam. So we're glad to be back after summer holiday, after having enough rest, and after preparing a bunch of other events. This is October's event. We really try to run at least 3 meetups a year. Sometimes we can achieve that, sometimes not. It's quite still hard to get speakers. So if you really want to speak and you have some topic on React, just please feel free and submit your proposals. That really helps. The more speakers we have, the always more events we can handle. So my name is Robert. I saw a lot of familiar faces here, so probably you've been at React Amsterdam meetups before. By the way, raise your hands. Who's first time here? I'm real curious. First time. Well, it's quite a lot. It's really nice. Like almost half of new joiners. It's really nice. That's why we also do the events, because we really want to engage with more people on the scene. And Amsterdam is always growing, so it's nice to see constantly new people joining here. My name is Robert. I'm an engineering manager at Hostmaker, the company that doesn't provide services in Amsterdam yet, because it's really against all the prop tech and Airbnbs in general, and that's what we do at Hostmaker. And I'm also organizing technical events, React Amsterdam, JS Nation, React Day Berlin, the conference we're doing in a month from now, and a bunch of other things. We're live streaming this event and all the previous events. We also record everything. So if you like the talks today, you can share the link straight away, either right now with your friends who can join us live on YouTube. To find it, it's really easy. Just Google React Amsterdam YouTube, and it will be one of the first results, or most likely the first one. Then, apart from live stream recording, we also always edit talks separately, so we can share that with our 5K subscribers on the React Amsterdam YouTube channel and get a bit more juice out of it, which is especially nice for speakers who spend so much time preparing the talks for you. We're, I don't know which time, like in order, we're back in Korea. Korea is hosting us for, like, I think 2nd year in a row already for 2 groups, and it wouldn't be possible without support of other companies in Amsterdam, Netherlands, and worldwide. So today's new partner is IJsberen. They're doing an innovation lab under MediaMarkt, and they do a lot of greenfield projects, React obviously, and they work with big data and mobile first applications the most. So if you want to check out their possibilities, they have like React architect roles and a bunch of other which are not regular senior roles. So it might be something interesting for your next steps. So this website is the same as the logo. Next to this one, we have another partner who helps us again to gather some budget to run this awesome venue and get some free snacks and beers. Is Evolution Gaming. It's a long-time supporter for 2nd year already. Each event is basically supported by them. It's really nice. It's a global company with multiple offices in Europe. They also have an office in Amsterdam since around 2 years. They do mostly WebGL plus React online games, which is also really nice if you're into graphics, into 3D, into React as well, which I hope you do. Otherwise, yeah, you probably wouldn't be here. Next to meetups, especially for the all newcomers today, we also do conferences. So we started doing React Amsterdam community in general around 3 years ago, almost probably even exactly 3 years ago in 2016. We started with Meetup, then we started with a really small conference. Then a really small conference became a really huge conference with the real 1,300 people in it. We've been aiming for 500 people at the 2017. But we just so hyped with React, still growing, by the way. If you look at the charts of NPM downloads, it's just like booming, breaking the skies. And we're returning with a 4th edition in 2019. It will be again in April, just when it starts to get warmer. We specifically choose always middle April between King's Day and Easter holidays. And few things you can take with you about the event is that we're not only trying to get the top international React speakers from all around the world. We also try to get as much as possible OS contributors, open source contributors, and try to mix the education with really fun times. We invest a lot of our team efforts into organizing nice parties. So there in the right top, you see one of the photos from one of the performances we had. Last year it was April 13th, which was a Friday 13th. That's why we had this horror story section. And we had a bunch of artists, invited code artists and different other artists that been doing lots of performances throughout the day and on the after party. So we try to make it different, not similar to other conferences. And a bunch of other things. The partners that works with us, we motivate them to bring something fun. So you can see some VR stands and things like that. We have boats. We have a boat transfer from Central Station, a daily event. We bring speakers on the boat. Speakers are staying in the boat hotel day before, so this whole experience, like Amsterdam on the river, really nice location, Krommenhol, which is just across the river. Yeah, some other thing that we started last year was React Open Source Awards. It was a huge success this year on the previous conference, and we'll repeat that. So soon we'll be announcing call for projects. So the projects you like in the year 2018, you'll be able to submit, and they will go through the voting, and we'll be actually inviting all the nominees, and then giving out the awards. So we have five nominations. I think we'll stick to those. It was really fun, and we got quite a lot of submissions last year. And the goal of this is first to create a real festival-like feeling of the event and the community. So we gather as much people from all around the world as possible, so you can meet them, so they can meet each other, as we're all online, and sometimes we just couldn't maybe even saw each other on the photo because avatars could be just anything. Yeah, we're really betting on a global community. We had a lot of US visitors and so on. So we're looking to get even more international, really global community into Amsterdam. And it's really good that we actually, like, Amsterdam holds that biggest React conference, which is not a marketing thing. It's actually like the biggest. If you Google, there's no other conference on React with more than 1,000 people. We have the tradition, since the very first React Amsterdam, we launch officially things as our meetups. So meetups is everything we started from. We'll continue doing meetups for free all the time. And we already pushed the early bird tickets live. Last year, they've been sold out in 34 hours. It's also not a marketing thing. If you really want to get the cheapest price, you can either do it in the break, either right now, either tomorrow morning. Maybe you'll be lucky and tomorrow noon it will be still there. But I'll be checking after and tweeting probably about the results straight after my opening. And there is obviously a call for papers and speakers open. So if you want to give a talk on the bigger stage or in meetups as well, just submit it. There's still time to try out your skills on this smaller stage. We'll help you. We have a bunch of other volunteers and experienced speakers who will actually coach you and help you succeed and prepare better. All right. It's second Robert in the corner. Yeah, that's pretty much it with the intro. The agenda for today is 2 talks, then a break, then a last final talk. And then we can party till the bar closes. Usually Korea Cafe is open like till at least 11, so feel free to hang out and ask questions to speakers you heard, and just generally network and meet each other. This time we also have some difference, like in the beer break, where people go to beers or run for the toilet in between the break, in between the talks. We'll also have a big screen games, a test flight. So we'll have tanks. There will be QR code on the screen. You'll be able to join and control it from your phone. So if you want to join that, don't run away. During the break in 20 minutes, we'll run tanks. And there will be also a scoreboard. And the first, the winner of the scoreboard, the winner of the tanks game, will get a free ticket to the conference. So there will be more motivation to shoot each other with more bullets or stuff. And I hope you'll enjoy it. And that's it from my side. Follow us on social media to not miss next events. And conference updates will be announcing speakers. We're ready to do that. And I will give the mic to our first speaker, Elko from FramerX. So yeah, let's give him some hands until he prepares. Yeah, 1 sec. Sorry about that. Did you say something?
Hello, hello, hello. There we go. Perfect. Let me clean this up. There we go. FramerX. FramerX is a tool for creating design and prototypes with real interactive components. My name is Ilke Lemsink. I'm the head of engineering at Framer. And I'm going to talk to you about a bit of the history of Framer and also how we built Framer and show off some things that you can do with it. So Framer didn't start out as an advanced design tool. It actually started out as an open source JavaScript library. So this is that library running in the browser. It was started by the founders of Framer, Koen Bok and Jorn van Dijk, when they were at Facebook working as product designers. And they noticed that being able to show off an interactive prototype on your phone that you could interact with, which was a much better way to sell your design than showing a slideshow of Sketch and Photoshop mockups. So this is how Framer was born, as an easy tool for designers to create prototypes. So after 2 years, they returned to Amsterdam from Facebook, and they start building a product around that library. So this is one of the very first iterations of that product. Very simple, code on the left, preview on the right. It didn't do much, but it already had, like, if you pay close attention, the code is CoffeeScript, so a CoffeeScript compiler in there that updated the web view on the right. So this product was called eventually Framer Studio, and over the years we kept adding features, building this out, and it actually was a product that taught a lot of designers how to code. A lot of products you know are designed using Framer. Also some products that everybody forgets, like Dropbox Carousel. I got this from our old website, actually. So to make coding easier for designers, we introduced features like autocode. So this meant that you, instead of typing all the code yourself, the preview was no longer just a static preview, but it was something where you could manipulate also the layers. We added like a big property panel in the middle where you could change the properties, and everything you did would actually write the code for you. So this was a way to get quicker into code. One thing you couldn't do yet with Framer, though, is build out a design really end-to-end. So you still started in Photoshop or Sketch to make your static designs and then make them interactive with Framer, edit things on top, stuff like that. So to make the end-to-end experience better, we started working in 2016 on Framer design. So this is built with React and TypeScript. So here it already looks a lot like a design tool, but there's still the code side. So you can get your design into code, share projects, and set up all kinds of interactive things in code. So this was already a nice step, but it didn't really feel like the future yet. So this was a good way to get design into code, but there was no way yet to get code into design. And this is really similar to how still some designer-developer handoff works. A designer makes something, then gives it to the developer, but then it isn't done. Like when you start creating the code, lots of things will change to the design, and there should be a loop. So not only should the design come to code, the code should also be available in the design. And this is what we set out to build with FramerX. So let me give you a quick demo. Let's see, yes, perfect. So this is the welcome window. So this is FramerX today. If you've ever seen a design tool, it looks very familiar. So you can set up your screens. You can draw squares, which is the most important feature. If you can't draw squares, then you're stuck basically. You can add text. There we go, something like this, resize it a bit. And we even have a graphics tool in there. So if I do this, let's see, I can draw some nice ovals, change the fill to add some stroke, position things, and I can use this to really quickly draw a very shitty React logo. Let's see. Oh, 120. Now a nice thing in the middle, right? Where's the middle? Perfect. We also have things like a color picker, which works on a complete screen. So this is still, even though this is web technology, it's still very much a native app. So this is the design part. There's also still a code part, so to attach some behavior to this, I can do something like this. I pull up the live preview. This is the live preview, and now when I tap the logo, I get some rotation. So just the basics. So let me prove to you that this is all web technology, and pull up an inspector. And you can see in the elements, so this is, there we go. Wait, this one is nicer. We have the canvas with all the elements on there. Like the elements I just draw, and even the drawings that I just made, they show up as SVGs in the, well, this is really tiny, but they show up as SVGs in the code. So what this allowed us to do is what I said, also bring the code into the design. So I can create very quickly, let me show you a code component. Create one, it will open, see this is nice and big, it will open VS Code. And this is like the demo component we throw in there. This is just HTML, very simple to get started. But it's this code running in the design tool. Okay, let's go back to the presentation. And I'm gonna, well, as a quick aside, now is as good a time as any to say we're hiring. We're always hiring. We're looking for great people. We already have a whole bunch of awesome people. Some of you are here tonight. You can recognize them by the Framer logo on their shirts probably. So talk to them or to me if you want to work at Framer. But let's get back to the program. So this is something that's probably familiar to you. You've seen this before. If you don't recognize this, this is Flux. So this is the pattern about data flow going in one direction. And the React part here is the view. Flux was invented before React, actually. If you're more familiar with Redux, you can scratch out dispatcher and replace it with reducer, which is like a totally different thing, but the diagram still is the same. And the point is the data flows in one direction. So this is what we used. Also in Framer design already. So we used very vanilla Flux for the dispatcher and the store, and we used immutable.js for our data. So our data that you see on the canvas, all the objects and the hierarchy, we called it the canvas tree, and we used immutable JS for it. Hard word. And this is a great library, and it really helped us ensure that we didn't make any mistakes when doing complex manipulations. The view, powered by React, is the canvas, and somehow we thought it was also a good idea to make the tools into React components. So this is what we did for Framer design. So this is one of the things we came to regret. Like, it was very nice, like, React, everything is a component. This is a very simple model, very simple to reason about, all the tests works the same. But how the tools worked wasn't that great. Like, a lot of logic and a lot of heaviness went into into the shoot component did update, and it got like the mouse position, and it had to check, did now the mouse position change, or did the data change, and should I continue updating? It was a mess, basically, so this was crazy. Another thing, Immutable.js, it's an amazing library, but for many manipulations, when doing many manipulations at the same time, it gets quite slow, especially if you just compare it to plain old objects. It's actually quite a bit slower, and this also became a problem for us. So this is something that we needed to change. And what this is, when we take a step back, this is a state management problem. So we have a very specific state in our app, and we need a way to manage this. And luckily, in React, state is like a very simple concept. So there are only 3 things that can cause an update in React, and only 3 ways that the state will change. And this is a very important thing to keep in mind also when you're looking at different state libraries that will help you with managing state. I think a good question to ask always is, where is the set state? So somewhere in the library, somewhere in Flux or MobX or Redux, whatever, there is a set state call or a for state call that will cause your React components to re-render. And understanding where that point is key to understanding how the library works. And similarly, if you want to build your own state management solution, where do you put the set state? So this is what we came up with. This is what we currently have. We have something called an engine. It still has the data flowing only in one direction. And it has 6 states. It starts idle, like an engine idling. And it can move to the event handling state when an event happens. There's tool processing and post processing which do all the mutations. So there's still only one part in which the data is mutated. In all the other parts, there are no mutations going on, and the canvas tree is completely immutable. But this is also a custom solution. So for the event handling, that's actually the only state that can happen multiple times. So for instance, if you move a mouse really fast, there might be multiple mouse movements that have happened before the tool processing gets its chance to kick off. And we make sure in the event handling state that all those events are processed and no tool processing has been done. So we only use the latest mouse position and then start the tool processing. And this saves a lot of rendering because the set state in this solution actually happens in the event handling. So when the event handling kicks off, we set a state on a top level object where we increase an update counter, and it will cause the whole app to re-render, but only once. So we set the state, and then the tool processing will still kick off in the shoot component update, but only once. So this will happen. The post-processing will make sure all the data is correct and do some other things. And then we have a single render in the application. We have one more funny state, which is called wait frame, and this is basically, there's like a micro task that we use. And after that, we are really sure that the browser has given control back, all the rendering is done, and the engine moves back to the idle state. So, as I said, this is of course really custom. I don't know if this to any help to your daily state management problems, but I hope it gave you some insight in what we do and maybe some inspiration if you need to build something custom. Okay, so let's move from the internals of FramerX to a bit more of the externals. So this is an API we added to React components when you use them in FramerX, and we call it property controls. It looks maybe a bit like prop types, which you know, but prop types are more for type checking and safety, things like that. And property controls are explicitly about adding UI to your properties. So this UI will show up in Framer. The code you see on the slide is TypeScript, which we use. Um, Same works if you just want to use plain old ES6. You just have to use strings for the types. There are many different control types, and I can go through all of them, but I think it's much nicer just to show you. There we are. Okay, so to demonstrate this, I'm gonna go to something else that's quite unique to Framer X, which is the store. So the store is where you can browse for all kinds of components for Framer X and install them in your project. And you can also, there's a nice publish button, you can also publish your own components to the store. So in this case, to demonstrate the properties, I'm gonna search for the properties component made by a colleague of mine, install this in my project. There we go, I want to show it. Okay, so now I'm in the components panel again. I have this, which I can drag out. There we go, so now I have a small component. And here on the right side, I have all my properties. This doesn't work nicely. All my properties, like the title, which I can change here. A color, which can be changed. And even an image picker. So I'm grabbing some unsplash image. See, oh, it's a bit weird, but anyway. So this is an image which now will be managed also by Framer. So you can add this to your component, and inside your component you will get the URL where it is. It will clean up images that are unused, and the same with files, lists, etc., etc. Okay, so this is all nice, I think, but let's try to build our own component now. So this is the third demo. And I'm gonna make something using existing React components. I don't want to start from scratch, but I want to make a chart component. So let's do that. Let's remove this already. Okay, yeah. So let's make a chart component. There we go. Okay. So I get now the component code again. And for this, I want to use the existing React components, as I said, so I'm going to open a shell. What happened to this font? I don't know. Okay, and what you see here now, so now I'm in the code directory, but this is the Framer project directory, and what you see here might look familiar, like you have a package.json and then yarn.log, and as you can see, this is really like any other JavaScript project powering this all, and actually I can use yarn here also. So I'm gonna add recharge, which is nice. And there we go. And I'm gonna also add the types, because I like types for recharge. There we go, and now I have it installed, and I can start creating my components. So let's clean up this. We're gonna make a very simple chart at first. Like for the data, we're just gonna use a list of numbers. And also we want a width and a height, of course, because the chart will have a width and a height. Okay, we have a class. Some default data would be nice also. Perfect. And now we can create some property controls for the data. So this is something we launched very recently. So the control type array, which will allow me to do an array of items just for the data. And now let's do it like this. I have subcontrol type, property control, property control. I'm typing very sloppily, as you can see, because I'm so used to Prettier cleaning up my mess that I don't even bother anymore. So this will be a number. Perfect, and it's cleaned up. There we go. And now we're gonna make a line chart. This one, So you see, this is like, I have the types and everything installed, right? So VS Code will automatically import it as I type the things that I need, like an x-axis and a y-axis and a line. There we go. And now we're gonna use our props. Oops. Like the width and the height and the data from the props. This is always very boring. Right, and the data I want to manipulate a bit to get like also an X value, which I'll just use the index for this. Let's say chart data is map, so I get the Y, and the index is I use as the X. X and Y, perfect. Go away. And that's what I use for the data. Chart data. And now for the x-axis, I want to use the X. And then the line, I want to use the Y. There we go. Okay, let's see if it works. Actually, oh, an error. Oh no, there we go. So it's been compiled. And I have a chart in Framer X. So now I can use the property controls because I set this up for data, so I can add more data points, change the data points right in the UI, move them around, disable them. I actually want a slightly nicer line type. So if I make a change here and save it, it will be compiled, reloaded. There we go, now we have this nice line type. Let's make it a bit, let's give the designers a bit of control, right? So a color would be nice. So for the color, some nice blue default. And a control for it. So for the color, the type, so this, I want to be a color, and this is the line color. And I want to use this, so get this from the props color and use it for both the stroke of the line and also the fill of the little dots on the line. Same color. And there we go. Nice line, nice color, and now I can use the color picker to change the color of the line, and it will update automatically. So that's a very quick and short demo. A very quick demo how you can do this. I used npm. This also means if I publish this component to the store, like the recharge will just be a dependency of my package. So it will grab that from npm when you install it. It all works like everything you know. I think what we're building on right here with Framer is the foundation of a new way for design and development to work together in a way that code and design can blend and go in both directions now. So if you also find this exciting, we're hiring. But mostly check out Framer at framer.com. I'm on Twitter at Ilko, and you can ask me anything during the beers and the breaks. Thank you.
about his talk. The regional title was converting React to Angular, which I changed to not frighten all the people coming here, and I made this double arrow because otherwise you would assume that React is dying and everybody is transforming their code to Angular, which is definitely not the case. And I hope Vladimir will explain more in details how it actually could be useful. He's a React developer, all good. Angular is here not because we have an enemy in the room, but yeah, give some help to Vladimir and let's hear the story.
Good to go. Okay, so I'm Vladimir Milenko, and I'm a front-end developer at Lightspeed. You know, something is incorrect in this setup because it shouldn't supposed to be mirroring. Let me fix it very quick. Okay, that's better. And one second. So today I'm going to speak about the abstract syntax trees and how you can use them to actually convert the components between frameworks, no matter if it's a React to Angular or Angular to React. And the first action I actually need today to do is to make a selfie, because we'll get back to you, and this is my first ever presentation, but this is very important. Like literally, it's one of the most important things, and yeah. Okay, we will get back to this photo a bit later. Yep. So, as I said, today we're going to speak about the abstract syntax trees and how we can leverage the universal syntax tree to convert one component from one framework to another. And let's start from the story. At Lightspeed, we have multiple products and retail, e-commerce, and restaurant. And at some moments, the company decided that, hey, we want to unify the UI and UX between all of our products so that customers will really feel that they're in one ecosystem. And there comes the problem, because the retail and e-commerce was written in React, and we developed the UI components library, which we are sharing between those two products. And for us, it's good, but for restaurant team, they just cannot use it, and they have two options: either to rewrite the whole UI library in Angular, or to switch the restaurant to React, which is also a good solution, but it will take a lot of time. So I decided that I can help with that, and I came up with the idea of universal syntax tree. But before we get to the universal syntax tree, we first need to know what is the abstract syntax tree. So what is the abstract syntax tree? It's very hard to tell. It's a tree, obviously, the data structure, and on the right side, you can see that this is not an abstract syntax tree, but it's a good analogy. Developers first start learning the programming from flowcharts, and this is the flowchart, but if you remove the right line, and you might probably remember that flowcharts are not actually focusing on how your code is written. Instead, it focuses on the structure of your code, on where you declare variables, what's inside your if condition, what's inside the block of if condition, and what's inside the else condition. So does the abstract syntax tree. It doesn't really care on how you write your code. Instead, it focuses on all the nodes, on every meaningful information in your code. And it just represents a meaningful part of code for the interpreter when you will run it. That's why you get all those errors when you try to run the code which is invalid, just because, well, you cannot parse the abstract syntax tree of this code. And yeah. So let's take a look at those two variable declarations. They're both valid, but for the right one, you will probably get fired because, well, it just violates every single style guide of how you should write the variable declarations. But for interpreter and for the parser, they're all the same. It's just a variable declaration with a value, and that's it. So this is how this node looks literally in abstract syntax tree, in case if just when we strip out the meta tags, which are used for different tools, this is how it looks. It has the variable declaration, it has the array of declarations with the variable name, which is the identifier type of node, and the init, which is the string literal with the value, and of course the kind of const. So what you can do with this code, you can modify it, you can analyze it to find possible issues, or you can even generate the human understandable code from this abstract syntax tree. And how many people there ever worked with the abstract syntax trees? Wow, that's quite good. Well, actually, you are all working with the abstract syntax trees. You just don't know about it. Take, for example, Babel. Babel takes your perfect skinny baby tree with the class methods, with your class properties, and then it just dumps it to unknown thing, but which runs everywhere. It's just because when it sees the node of a specific kind, it uses the plugin, and then this plugin outputs some kind of information. That way, when you declare a class, it just creates a function call class check, then it creates a function to generate the class properties to append them to the object, or class methods to append them to the prototype. And then, yeah, after running the Babel on your code, it basically, you get rid of all the fancy nodes, and you only end up with something which is supported by the target environment you're looking for. Another example is Prettier, and it was just mentioned in the previous presentation. The Prettier is actually parsing your abstract syntax tree, and then it generates the human readable code based on the set of rules it has inside of it. That's why it got some it became that popular that, yeah, it just takes and generates whatever you write based on the rules it has. Another example is the ESLint, and it's used for analyzing your code for breaking the rules, or even to analyze the possible issues, I would say performance-wise anyway. It just looks for a potential issue, looks for potential wrong usage of, I don't know, specific nodes, and then just, okay, you need to fix it, otherwise you're not going to pass the CI. So just to remind you, the abstract syntax trees are suitable for code modification, code analysis, and generating the code based on it. Now we're a bit more familiar, and we can actually get to the universal syntax tree. And it's something in between on how we understand code and how the machine, and how it's being parsed and how the machine understands it. It's a high-level tree which just tries to see the familiar patterns in your code and then generate some kind of definition on how it should be working. It is not meant to convert the whole project, because this is almost an impossible task for you to do. And you need to think like, yeah, if I want to convert a project, this means that this tool needs to know every single line of code, every single pattern I use, and it's almost impossible. Instead, it focuses on converting the specific components, which are smaller and which are easier to just to process, because we all use pretty much the same patterns on how you structure your code and how you do some stuff. So, and due to its nature, the tree itself is target and source agnostic, which means that if you have the specific parsers for React and specific generators for Angular, you can parse React and convert Angular. If you have specific parsers from Angular to React, then, well, from Angular, then you can generate anything. And as I said, it's not a direct conversion. Instead, it sees the pattern, and then you have the generator, which knows how this pattern is being generated in Angular. It's like, you cannot convert just the Turing complete language into the HTML. That's just impossible. That's why it's using the TypeScript on the one side and the template generation as a side effect of this. The tool set is pretty easy. The AST parser, Babylon, the AST node types, Babel types, and you can pretty much see it on the slide. And the issue with the parsers is that most of them are similar, but sometimes you have TypeScript, for example. And this is why you can't use ESLint in TypeScript, because the TypeScript parser is actually having the different kind of nodes, and ESLint just cannot support it. It just has another parser, while most of them are actually similar. And yeah, you just cannot use the same predicates for multiple parsers. Now let's take a look at the following J6 node. Pretty straightforward. The render node, the children, and the text node. And you would say, hey, you just renamed the abstract syntax tree nodes into some kind of universal syntax tree. And yeah, that's pretty much it. You have the render node, children, and the text node. But, okay, sorry. This is the representation of this JSX node in the universal syntax tree. Just type, tag, attributes, children, and etc. And it's basically equal to the right side. But this is where things get complicated. At this moment, when you look in the tree, you're basically getting lost because, okay, you have the render node, which is fine, we can keep it. But then you have the JSX expression. Then you have the some kind of call expression, which is taking some kind of item, calling some member of it. Then you have the arrow function expression, which has the render node output, which has the attributes with the JSX expression, and which has the children of us also as the JSX expression. But what do you call it? It's just, yeah, it just renders an array, right? And you can, even if I add like filtering or anything else, you will still look at it and say, hey, this is just an outputting of an array of items. And this is the core idea, because if we say that, okay, if you face some kind of item, some kind of expression, where we're actually calling the map function, because the map function is only an instance of, is only exists in an array. And we say that the contents of this function is an arrow expression with the body of the JSX expression. Well, that's something already we know, and we can try to think that it's a render loop. And this is how it looks in a predicate. You have the isMatching function, which is being run on every node you process in your abstract syntax tree. You check if it's a call expression, if it's a member expression, if the callee is a member expression, if the property is identifier, and then you just check that the function you're actually calling is map. This gives you an insight like, okay, this is a map. I can use it for conditions in a good scenario, right? And then you have this parser thing, which is actually taking the arrow expression function, takes its body, and then just, okay, somehow resolves it because it has the set of the same parsers, which are in the end outputting the UST nodes as a children. And then you have the base item, which is the name of the array, the variable you basically use, and then you somehow resolve it. And you return the UST node called render map with the base item, with arguments, with children, and the mutations of this array. Because this is also important because you're going to need it when you start basically generating stuff based on this. And we ended up with an unknown call, the variable registration. And this is the point of complexity because you never know where the variable is coming from on the first look. But it's a basic dynamic programming task. And each time you traverse the tree, you see some kind of identifier. And you can assume like, okay, if I go somewhere on top of this tree, I will definitely find something which shows that, okay, this variable was declared somewhere. Then you will go deeper, deeper, and deeper, and then in the end, you will find out that you have only few sources of it. I specifically missed the context because this presentation was made before the React 16.6 released, and the context was stripped away. Now I have to add it again. So you have multiple sources, which is the props, state, and a closure. And to make the information about your variable meaningful, you need to understand the source of your variable, you need to understand their usage, and understand the mutations. Thankfully, Babel Traverse provides you with a thing called scope, and you can basically get all the bindings from the variable, and you just then can get where the variable was declared, then just go up and up. And I'm sorry for this being in Angular, because yeah, I know there are all guys from React. I'm just using React as a base, don't worry. So this is the template generation, because as I said, the Angular is using the HTML templates in it, and this basic generation of the render node on how the generator will actually process this node. It will take the node identifier as a tag name, it will take the attributes and convert them, and then just generate all the children of it. And look at the code, because yeah, the new array doesn't sound good. I can just put the array, but it's fine. And at this point, the code doesn't really fit into presentation. And it might get a bit boring, but I will try to make everything as smooth as possible, and I hope that the demo in the end will impress you. So now I'm switching to the code, and I will I will first show you how you can parse the React's logical expression. Basically, the conditional rendering, when you have some kind of condition and the output is being kind of, how do I say this? Depends on the what you have in your output. So we will take a look at this. This is the basic construction in React. You can see it, hopefully. Just, okay, you can see it. Yeah, just a basic expression. And we assume that this is always a G6 expression container. And then we're going to try to parse it. But first, we match it. And in this talk, since the UST is still in phase of the very, very early stage of development, I'm limiting myself that if I see the ternary expression, I assume that the consequent and the alternate values are actually the JSX nodes. So it's not like kind of blocks of code. Instead, it just returns something. And I assume that the condition is either an identifier, either a logical expression or an unary expression, and while you want to, for example, render something if the variable is false. And whenever you found the matching predicate, you basically need to generate the universal syntax tree node to move it then to the next step of the generation code based on it. We just parse it. So we call we take the expression and we just try to resolve every variable which pops in there, just to make sure that whenever we generate it, we will have in our resolver registry enough information on what variables are being used in this particular case. And yeah, then we just return a very interesting thing, because we return the type, which is conditional renderer, we return condition, but also we return the value. And the value in this case is not the universal syntax tree node. It's actually the abstract syntax tree node we're going to use later for generation. And then we again just trying to resolve the consequent and alternate values. So one more thing is, this is going to be hard. Sorry, guys. Okay, this is actually the generation of the Angular class. How many people there are familiar with the Angular? That's good. Okay. How many people here are familiar with this shit? Cool. So, as you can see, I can call it, you can see, yeah. It's just basically creating the abstract syntax tree from scratch, but then we also need to append the input properties, because we just parse them and we're like, okay, you need to get this data, and we will generate them with appending the decorator, with appending the name of the variable, and in case if this variable has any mutations, we will just, okay, this is fine. I'm going to have the getters and setters for this variable so that I can use the private internal variable which is being generated as an output of input props. Was it hard?
Yes.
Thank you. I hoped it's going to be hard. Okay, this is the final step before the demo, I promise. We have the generator of the conditional render. We have the generator for conditional rendering, and we take the consequent and alternate values. We generate the actual HTML output for this, and then we take the condition specifically for this presentation. I made it to look like something user-friendly, well, if you can call it. Then we have the consequent node, which contains just an HTML node, but it has the attribute of the template name for Angular, which is being used then. And you have the alternate node, which is pretty much the same, but with the reverse condition for it. And then you have the condition, and this is where things are getting interesting, because you have the ng container and you have the ng if. In Angular, you don't have that much of the power in controlling on what you're actually rendering, the if and else blocks. And you need to use the pattern called ng container and ng plates, because the ng container will actually decide what's going to be inside of this container. And we have the condition, like, okay, if this condition is true, then we're going to take the consequent node identifier. Otherwise, we're going to take the reverse condition node identifier. And okay, you remember the picture I took at Yes, it's uploaded. So I have the very interesting thing there. I have the, I don't have it running, but I will run it now. So I have the Create React app being running in the background with some kind of project, and on the right side I have the Angular project being run. You can see that it cannot find some stuff. Oh, it's usual for Angular, it never can find anything. But yeah, right now, if I show you this Angular test application, you can see that the components folder is empty. And in my React applications, I have those components, which are pretty easy. This is an easy component, just used to output the comment. This is also pretty easy. Just take profile picture and some props. And this one contains actual code, because it checks whether you have the comments loading, whether you have the posts loaded, and etc. And then just uses its own components like profile and then maps through the comments just to render them. And it looks like this. So this can be closed. No, I actually won't show it. I want to show it both. And don't look at this demo true. It's just because it needs to take the specific files from the specific folder. And then I run it. And now I'm going to open this very, very simple index.html. No, not this one. Sorry. I'm going to open this file, which is just the iframe to two running servers on the local host. And okay, to open it, I need to actually go there. Okay, this is not how it was planned. That's Angular, but that's usual. Seriously. You never can trust what you're running. And this is the components. The right one was actually generated from the React components on the left side by just parsing the nodes. And I can literally prove it to you by showing what's now inside of those Angular package components. So this is, for example, the comment. And it has this content inside of it, which is just few props and then the selectors and etc. Have the pretty much the same profile component. And if I go to the post component.html, you can see the actual pattern on how the conditional rendering is being applied and how you can iterate over the components and generate them based on the React source. And all the props are still here. And you can see that I have the very easy component. Sorry, it was access token. I need to revoke it now. You can see that we're just making a request to post and updating some local state of the component, which is exactly the same in, by the way, this component is not being generated. This is too hard for now. So this one, again, the success token. This one is doing pretty much the same. It just renders the post based on some data you have. So that's pretty much it. It's still in a very, very early stage of the development. But as you can see, this one is actually the Angular one with all the props passed to it, with all the items generated from the bindings. And this one is the React one, and they're exactly the same, but the code inside is completely different. This is what I call the pattern generated code. And yeah, thank you for your attention. I would love to answer your question, because maybe you have a lot. Yeah, subscribe to my Twitter. You can find the repo in my profile on GitHub. I forgot to insert the link. Sorry for that. I will also push the latest changes. And yeah.
Thanks a lot, Vladimir. Let's actually do a few questions because the topic might be a bit too deep or controversial. So if you want to ask a question, just raise your hand. I'll give you the mic.
I just want to know about the other way around.
The other way around. Okay, how often you face an issue that you don't have the Angular, you don't have the React component, but you have it in Angular?
I've got a big ugly Angular code base. I'd like to be in React.
Okay, so the thing is, the whole idea of universal syntax tree is that it's completely independent on what you have as an input and what you have as an output. And to convert the components from Angular to React, you will just need to write the parsers for it. I will do this, I promise. In half a year, we will have working Angular to React conversion. Because, well, the converting the Turing complete into the non-Turing complete and Turing complete languages is quite straightforward because you can parse it pretty much, you can parse the predicates pretty much easily thanks to the abstract syntax tree. When it comes to parsing the non-Turing complete and then understanding what's happening on the Turing complete side of it, this is where things get a bit blurry, and yeah, basically in React we are pretty much constrained with the one file, and yeah, you just have some imports and etc. But with Angular you will need to look very, very deeply at all the patterns. And to be honest, I'm not an Angular developer. I don't know all of the patterns. If I would start as an Angular developer, I would definitely start with converting from Angular to React. So as I said, yeah, you just need the parsers and generators. That's it. Any questions more,
yeah,
please?
There's another one here.
Yeah. So it's meant to be actually going to be used in production?
I hope so.
You've got a customer who's paying for this? Or?
No. We have the project which we want to share with our Angular team, and we just want our team to be able to use our shared UI components library without touching it, so it can be automatically generated. That's the whole goal.
And
It's
then-
open source.
And then I'm curious, who's the team?
Well, right now this thing is working only me, but you can find my two fellow front-end developers over there, and the team lead is somewhere in the back. Yes.
Okay, thanks.
Any more questions? Or we go for a break? Right? Yeah, you can still catch Vladimir at the break or after the talks in the networking part. And right now, we'll continue with the break, 20 minutes. Be back here in 20 minutes. And at the same time, Dennis will be launching the Tanks game with the option to win the React Amsterdam ticket. So yeah, break 20 minutes. And good? Or anything help? All right, and the final speaker for the evening before the after party is Roy to speak about ReasonML. I really believe Reason will be the next thing after transpilation. So I really hope you enjoy it, and please welcome Roy.
Hi. Yes, very nice to be here tonight. I already saw some really interesting things and also some familiar faces from the React community in the Netherlands, so that's really good to see. So let me get started. So it's ReasonML for React. So what is this about? Of course, it's about React, it's about Reason, and I will show you how you can benefit from all the extra functionalities from Reason inside a React.js project. So React Reason uses OCaml, which is really not really different from the JavaScript syntax, but it's a small difference, and we're going to deep dive into to see how that works for you. So this is actually a meme from I believe Zoolander saying that ReasonML is so hot right now. For every JavaScript developer, the possibilities are endless, and there are new features, frameworks, or other interesting stuff, packages coming to the community every day. So ReasonML is not really one of those packages, but it's really an extension built with a different syntax, but allows you to really explore all the interesting stuff that JavaScript has. And for those people that are thinking it might be in hype, or maybe another framework that is being overhyped by the community, it is not. It is actually built by Facebook. Along the same time they built React, and actually React was meant to be built in something other than JavaScript. So that's when they came up with Reason, and he kept it sort of under the hood. But now you have Messenger.com, like Facebook Messenger, and it's almost for 50% built on Reason. So I believe it's a real game changer, and also Bloomberg adopted it into their ecosystem. So let's look at it. So let me tell you a little bit about myself. So I'm Roy. Next to developer, I'm also an entrepreneur, a startup CTO, and I tweet a lot about JavaScript and everything related, like the newest frameworks or packages. I started programming when I was like 16-year-old, and I wanted some extra money, and my parents didn't want to raise my pocket money, so I got into development. I checked how I could make a website, how I could sell website to other people, and eventually created my first marketplace that was used to buy and trade used DVDs for other people. I really started learning out by myself, and then I went to university, I learned even more, and then JavaScript came my way, and I started all the way from jQuery to React, React Native, and even ReasonML right now. So what's this presentation for? Who here uses TypeScript? And Flow? Okay. I'm not really sure, but do the people that use Flow already know that it's also built on top of OCaml, the same as Reason? Okay, that's good to hear that some people at least know. Yeah, so TypeScript and Flow, they both do some stuff that Reason also does, but a little bit different. So let me first explain what Reason is. So Reason is built on OCaml, and OCaml has been around since somewhere in the 1990s, and it's been it's an ML language, which means it's really functional. So JavaScript isn't perfect, and some people believe Reason is, or at least OCaml is, so people started to develop ReasonML on top of OCaml, which you can compile to JavaScript using BuckleScript, which is made by almost the same people as that made Reason, and you could use it to compile to JavaScript. Natively, Reason can also compile to stuff like assembly, or maybe other languages if you use the right packages, like BuckleScript is for JavaScript. So who's this really for? It's mostly for the people that are sort of irritated by the stuff that JavaScript likes due to its dynamic type system. And that's basically one of the reasons for me to say why not just use JavaScript. JavaScript is fine, but it lacks some stuff. I use JavaScript for almost everything, ranging from web applications to mobile applications to APIs or microservices or even machine learning software. But the biggest downside remains its dynamic type system. What will types do? Maybe some people don't really know what types are. With types you can really define the structure of all the data that flows into your application. So it will improve stuff like code readability, detection of code errors. It also will give you some analysis about your code. There's really cool IDE support, so the people using here that are using Visual Studio probably know about all the extensions for TypeScript or Flow to really make their development experience really strong. And also refactoring becomes way much easier if you've got all these types and you know what data is flowing into your application. So why not TypeScript or Flow? As a lot of people are using TypeScript or Flow or maybe both. In my opinion, they offer like a partial solution to the problem of the dynamic type system of JavaScript. TypeScript is probably the most popular if you compare it to Flow. More people are using it than people are using Flow. But still you need stuff like Immutatable.js or runtime packages to really get everything like pattern matching and that kind of stuff. So for me, TypeScript is still not really soundproof. And I believe reason is. It's almost impossible to inject, or I believe it's impossible to inject data that's malicious into your JS code base. And that doesn't apply to the type system that you've set before. And with Flow, Flow is also built on top of OCaml, and it runs on top of JavaScript, so why not just use Reason in the start? So let's get started by creating a Reason React project. We'll use a package called Reason React, and we will also use the BuckleScript platform to transform our Reason code into JavaScript. And along this presentation, I will use JSX, which probably most of the people that are using React are using. You can also use it without JSX, just as you can use JavaScript and React without JSX. But for now, I just stick with JSX to make it more readable and clear for everybody what's going on. So BuckleScript can be installed just by running an npm command, and after that, you can use the BSB command to initiate your first React app. And something that's really important right here is that you also add a team called React to your application, so you can really get the React development experience. After that, we just install the new project and we run it. And then something what might feel a little bit odd is that Webpack isn't integrated in the process, so you have to run Webpack in a different terminal or command prompt. And as you can see, we got a really nice structure with inside of our new application. And the really important stuff goes on in the RSC, in the source folder, with the index.html, where just as with React, our source code is built, and the index.re, what is our reason code, and the index.bs.js that is compiled by BuckleScript. You won't need to change something that's inside the index.bs.js, because BuckleScript does all the hard compiling for you. So first start by seeing what a Reason stateless component look like. Like this is the stateless component you probably remember from all the React applications you've built. So we just import React, we create a small stateless component, and we render it using the React DOM. In Reason, this looks a little bit different. As you can see, we still have the React DOM, or somehow a different version of the React DOM, where we inject some JSX with a prop called React Amsterdam in this case. And we define our component, and then all the magic happens inside the make function, where we define our prop. So in this particular situation, it is only name, which we will render, and then we have a Reason React string that outputs hello name. So below you can see the output that this function will generate. And then, so here we have for JSX, and we have the props and the output of the props. And this sort of compiles to the React create element binding that is in Reason React. So so if we would define the strong type system for Reason, we can mostly easily do this just by changing our prop. So our prop used to be a string called name React Amsterdam, and now we changed the name is 9. What would happen? As you can see, inside your terminal you would get an error message saying like this. We would expect a string, but we got a type. And it's, we got a string, but we expected an int. We got an int, but we expected a string, sorry. a bit messed up here. Okay, so as you can see, we get this error in your console, and you know immediately that you're doing something wrong. And that is really from Reason's strongly typed system. In JavaScript, you would get something like undefined variable x, blah, 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 or you can't read null. And for this, it's a real game changer. So now if we would send some other prop to it. So we used to send just the name property, and now we're also sending visitor, which is an array containing just the strings called visitor. Inside of our application, we have set the type for visitor that is fairly different. So let's see what it would make up. And then again, we would get an error saying like, hey, this is not what we expected. We expected our list, as we composed here. This is something other that Reason React is doing. You can create a list in a map function from just an array of objects, and they automatically map it for you. So we get an error because we gave the wrong information to our function. So suppose we give the good information to our function, it would look something like this. And yes, as you can see, our ID is an integer and not a string, so we have to transform it from an integer to a string, so we can use it with the Reason React string binding. And then the output will look something like this. So we have some divs containing the number of visitors we put in initial props, and then saying hello React Amsterdam. And next to stateless components, you also have stateful components. And stateful components, they can access the life cycles or even mutate states, that kind of stuff. So in React it will look something like this. You have your constructor defining your initial state, and then you have multiple lifecycle changes over that. So like the component did mount, you can also put in other ones. And then ultimately you render your function, and the React DOM will take care of the last bit of that. So suppose we're going to make a stateful component in Reason. It looks a little bit different, and it's also not called as the other component was called the stateless component. This one is called a reducer component. And with the reducer component, we can access all the life cycles that are available in React, but just with all the type handling we saw before. And wait a minute, we're going to try to make a reducer component without defining all the route type info. So we need to define the make function, define the reducer, and also give it a new state. So as you can see before, we just used our regular stateless component and tried to make a reducer component out of it. Something that happens a lot in React is that people use stateful components for stuff that could also be stateless. So Reason helps you by notifying you that you're doing something wrong, and that you could also make a stateless component. And if you want to make a stateful component, you need to add the right properties to it. So now we added the state, and in this state we expect visitors to be a list of visitor, and visitor will have all the information of that visitor inside. So we used the name and ID before, so we're going to make that a string and an integer. But if we don't do that, we also get an error like, hey, where is visitor? So we're gonna put the type visitor, which we access in our state. We're gonna put it a little bit up, and then our code will look something like this. I hope you can all read it. But let's start at the beginning. So this is the entire code for a stateful component. So we're gonna start by defining the state. So this is where you give the format for the data of everything that's inside your state. So you define if something is an integer or a string or maybe an array or a list of objects. After which we're going to define the actions. So it's a bit comparable to Redux. You define the actions here that you can access later on. After defining the state and the actions, you're going to declare the initial state inside our make function. And the make function is it's like the class in React. Here we're going to define our initial state. We're going to give up like count is equal to the length of the visitor list we have, and visitors just equal to the visitor stuff. And after that comes the most important part, and that is the reducer. So in a reducer, we have a switch statement where we can access our actions, and our actions can update the state. And for here, it looks quite easy. We're just going to update the count a bit, so we would have more visitors. But if we're going to zoom in on this part, As you can see, you have here something that's called self. Self is the equivalent of this in React. So you don't have to deal with all the this dot blah 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 anymore. Everything transforms to self. And as you can see, we use the self.send here to access the action. And our action will mutate the state we've declared before. And next to just updating the state, like you can compare it to set state, we have different kinds of bindings from Reason React to update the state. So we just have the regular update state with which mutates entire states. We also have side effects. So next to just updating the state, you can also update different states or execute another function. You also have side effects that don't exec self. So you see self and underscore self. Underscore self is where self is neglectable. I forgot something. Yes, and in the end we have update with side effects, so you can update both the states and both send the state we can access through self to a different side effect, so a different function or maybe a different component that you also would want to update or do something else with. And if you go to this is another thing that comes from the strongly typed system Reason has. As you can see here, we can just use the spread function to spread the state inside our mutated states. I've added something along the end to increment our number of visitors and also to add a new visitor object to our array. As you can see, we would get an error inside our command center and our terminal that states all the fields are already explicitly listed in this record, so you can move the spread. So as you can see, we just have two parameters in our state, and those are count and visitors. So we don't need to use the state spread anymore. And this is something that's really cool that Reason does. They update you with this kind of information. So we can just remove the spread state and then we will be fine. And it will look something like this. And our output will look something like this. So this is generated by the Reason React DOM. And this probably looks maybe a bit overwhelming and maybe not everybody could tag along. But we can also use this inside a React application. And all the Reason React bindings gets compiled and you can actually use them inside our Create React application, which is something I will show you in a bit. So I assume we have installed a Create React version 2 application, and we're going to use the component we just created with Reason inside of this Create React application. So first, we need to add the BS platform and Reason React to our Create React application. After which we will place a BS config.json inside of a root project, and this is where all the compiling settings are listed. So as you can see, you have the Create React JSX setting for Reason in above. Below you have the BS buckle script dependencies for Reason React. And also we have set a specific folder where we're going to place all our Reason files that need to be compiled to bs.js files. So the next step would be to edit package.json to use buckle script. So for this is the command to run buckle script is bsb make world command, and this will start the compiling process from Reason folders to all the stuff you need in bs.js. So if we would have, so assume we have our component from Reason again, so the let component, the let make, then we need to add something below to define that we want to transpile this to JavaScript. So in here you can see that just below the make function, we're gonna let bucklescript know that we need to define some JS props, and those are props that we can inherit from the JavaScript application into this Reason component. So now we're going to say we're going to accept name as a string, and we're also going to accept visitors as a list of the object visitor. After which we're going to make a default export. You could also export multiple ones and then import them differently, but for now I just keep it by one default. So you see the reason React binding for web reason for JS. We're going to put in our component. We're also going to send our JS props in there, and we have another make function that makes the component we want to use in our JavaScript application. So we're going to send name and JS props. You can see the error with the name get. It's actually something that comes from the bs.deriving abstract, and this makes sure that we won't get any malicious data from the JavaScript application into our reason component. So as you can see, that's the first part where we really define the type for our JS props, and then we're going to export them here. So how would this look like inside of your React application? You might remember the JSX declaration we did before. So we have our component. It's called intro for now, and we can just import it from our reason components folder with the right file name, and then we can just put in some JSX to also send the props in there. For we have the name React Amsterdam and also visitors, which is now empty. But you could also send in some other states you derived, or maybe you have Redux running in your React application. You can also send those values right to your reason component. And for this, I will try to show you the real life code. I'm not sure if this will. Yes, it works for the first time. Okay, so I hope you can all see this. So here we have our React application. Which is created with create React app. We have our React scripts running, and for the build process, we're gonna start with make world, and then after which we start the React server. So as you can see, the only things I added in here is this part where I add the command for Buckle script and the dev dependencies, which are the Buckle script platform and reason React. After which, if you might recall, we also need to add in a bs config file where we have resources, so our reason components folder, which is right here. And we're going to say that the output should be bucklescript.js. And we're going to use reason React for it as we have a React application. Okay, so if we go inside the source reason components folder, you can see our reason file right here. Let's start at the top. So we have declared our types, we've declared our state, we've declared the actions to add and remove visitors to this list, after which we declare a component, and it's a reducer component, so it means we can access all the life cycles. After which we're going to start the make function, set the initial state, which is here derived from the JavaScript threads. So everything we send here, so the name and visitors, can be accessed right in here with name and visitors. And children is something that's reason asks for it. I can go into details, but it's probably not important. With the underscore, or you can just use underscore, whatever you want, to let the reason know that these are the children. And in a reducer, we're going to access this the state. We're going to change it. So we have add and remove. We also have our list here again, and as you can see, we have this button that adds a visitor, and we're on this one that only detects count right now. It would be like a little bit overkill to make something that also deletes the last object from it. But as you can see, it works just inside our React application while it's not React. So this bottom part makes sure that we can execute it in here. It's a typo, I'm not sure why it's in there. So as you can see, we've just created a regular React application with reason inside of it. So, yes. So what else does reason has to offer? So we just saw we can use it inside a React application. It also compiles naturally and natively to something like assembly. And you can also, with a strong type system, you won't get any null errors or undefined errors, and it's almost impossible for malicious data to go inside your application. And it's also very specific. It also allows for runtime pattern matching of variant types, but it's most fitting to transfer to JavaScript. So if everything else fails, you can also just insert raw JavaScript into Reason, and it will compile very well. So if you might think, why do we need a different syntax to achieve this? We have TypeScript or Flow, like I mentioned before. This is like an addition to that. You don't have to use it if you want to access its most supported features. Like some of them are already in TypeScript or Flow. But if you want to do something new and maybe want to insert some more functional programming into your daily life, then you could use ReasonML. And in terms of security, it's the best you can get, as its type system is 100% rock solid, and yeah, it will save you a lot of time on checks and unit tests and all that stuff to get to know more. So if you want to actually get to know more, then you can go to Twitter and find me there, or you can go to the ReasonML website, and the code I just sent to you can also find that code on GitHub. So you can use it, you can clone this repository and use this actual application at your own home, or maybe make your own Reason component, which you can also insert in React Native, by the way. So yeah, just let me know if you have any questions, or else that will be it.
Thanks a lot, Roy. So we finished a bit earlier, but let's continue with QA in the bar.
Yeah, cool.
That was the final talk for this evening. I just checked, we still have a tap on the bar. If you say React Amsterdam on the bar, you get free beers. We still have 70 euros left over there. React Amsterdam early bird tickets are going fine, 30 tickets out of 100. So if you really want to be an early bird, just grab your manager or whoever have the access to the credit card and just buy it all. And that's it. Thank you all for coming. We'll be in Korea Cafe, I think, till like 10, 11. So feel free to hang around. Thanks a lot for coming, and see you next time.